In this video, we'll discuss matrix equations, specifically how you can use matrix equations to solve systems of equations. Here's the technique. Suppose we have a system of linear equations. In this case, let's just use two variables. It'll work for three, but for now, let's just use two. We're going to create a matrix called the coefficient matrix for the coefficients on the variables on the left-hand side of the equation. This coefficient matrix will contain the letters A, B, D, and E in that order. Let's call this coefficient matrix capital A. Next, we'll go ahead and create another matrix for the variables x and y. Because there are only two variables, we will have a 2x1 matrix. We'll call this the variable matrix. And we'll use a capital X to denote this matrix. So when we multiply matrix A by matrix X, we get the left-hand side of this system. You can see that we have this A multiplied by this X plus this B multiplied by this Y, and that is AX plus BY. Similarly, our next line in A would be D times X plus E times Y, which is this dx plus ey. So that's what happens when we multiply matrix A times matrix X. We're going to create one more matrix here, and this is going to be the matrix for our constants that are here at the end of my system. So again, that's only two values here, and so we're going to say that product is equal to the constants, and those constants are C and F. We'll call this constant matrix matrix B. So let's put these three matrices into an equation using the letters that represent them. So that's A times X equals B. This is our matrix equation. Now, when we're trying to solve a system, we're trying to solve for matrix X, right? We're trying to solve for X and Y. So we want to know what these two numbers are in this matrix. So if we want to solve for this matrix, this guy right here, this variable X, what can we do? Traditional algebra methods would tell us, we'll divide by A, but do we know how to divide matrices? No, that isn't something that we've learned how to do. But what we do know is that if we multiply A by its inverse, the identity comes out. Multiplying the left-hand side of this equation by A inverse means we also must multiply the right-hand side of the equation by A inverse. But because matrix multiplication is not commutative, it's important that when I multiply A inverse on both sides of the equation, I do it on the left-hand side of each side of the equation. So A inverse is on the left-hand side of B, and A inverse is on the left-hand side of A. Now what we notice is that when I multiply those two together, they become the identity, whatever n size we need. I guess it would be a 2x2 in this case. So I have the identity matrix times X on the left, and I have the product of A inverse times B on the right. We also know that the identity matrix times any matrix just is that matrix itself, right? The identity matrix doesn't do anything to a matrix. So the left hand simplifies to just X. The right hand side is the inverse of A multiplied by B. But we've done it. We've solved for X. So the way that we are going to solve this matrix for X, which therefore gives us the X and Y that solve this system, is by multiplying the inverse of the coefficient matrix by the constant matrix B. So all we need to do is find the inverse of this matrix and then multiply it by the constants, and we'll have the answer to our system. So let's go ahead and get a system on the board, and we'll give this method a try. So here we have a system in three variables, x, y, and z. So let's start off with our coefficient matrix, which are going to be all of the coefficients on the variables x, y, and z. So this is going to be a 3x3 matrix. So here's our coefficient matrix. On the previous page, we called that coefficient matrix A. Now we want to go ahead and identify our variable matrix, which we called X. And our variable matrix in this problem consists of the variables X, Y, and Z. And then we know that when we multiply those two matrices together, the system tells us that they equal the constant matrix, which is the numbers that are on the right-hand side of our equation. We call the constant matrix B. So our matrix equation right now says A times X is equal to B, and we know that we can solve for X by multiplying both sides of the equation on the left-hand side by the inverse of the coefficient matrix. So that means that X is the inverse of A multiplied by B on the left. So then our first step in order to do that equation would be to find the inverse of A. So the quickest way to find A inverse is to use technology, but if you have to do it by hand, remember the method is to put the coefficient matrix into an augmented matrix with the identity, and then row reduce it until the left-hand side becomes the identity, and then the right-hand side is the inverse. So now that we have the inverse, we want to multiply that inverse by B, the constant matrix. So multiplying A inverse by B, the constant matrix, we are going to get a 3 by 1 matrix, right? Because this is a 3 by 3 and this is a 3 by 1. So these are equal, so that's good, but this is the size, a 3 by 1. So we need to take all of the rows in A inverse and multiply by this column. So this row by this column will give me this first position. This row by the 1 column will give me my middle position, and my last row multiplied by this blue B column will give me this final position. When I do that, I get the entries 1, 2, -2. So remember, this matrix is X, and X represents the variable matrix, so that means each of these are X, Y, and Z. So the solution to my system is the ordered triple 1, 2, -2.